Hello viewers, in today's session we are going to discuss an important property of Dirac delta function, right? And here in this class we are going to prove this important property related to the delta function, that is delta of square root of x minus square root of a is equal to 2 times the square root of a delta of x minus a. So here we are going to prove this important property using another important property of the Dirac delta function, right? So here we'll use the property of Dirac delta function, which says that if we have a function, say g of x, and the Dirac delta of g of x is given by sigma, and here we have I, and delta of x minus xi divided by the absolute value of g prime of x of I, right? So this property is going to be used to prove this one, right? So let us first quickly see this property, and let us understand the nature or the meaning of these terms, right? So here this I denotes the number of roots of the equation g of x is equal to 0, right? So when we solve this equation, that is g of x is equal to 0, then let us assume that the roots of this equation are given by x1, x2, x3 up to xn, right? So our I, it goes from 1 to n. So here we have the values of I from 1 to n, right? So x1, x2, x3 up to xn are the roots of this equation g of x is equal to 0, right? So now we can write this property as the delta of g of x, and here we have sigma, and I varies from 1 to n, and here we have delta of x minus xi, and the mod of g prime of xi, right? So g prime of x is the derivative of g of x, right? So here we have g prime of x is equal to d by dx of g of x, and we have to evaluate the derivative at these points, that is at the roots of this equation g of x is equal to 0. So let us come to this property. So here what we will do, we'll take this expression as g of x, right? So let us take g of x as square root of x minus square root of a, right? So the first step is to assume that this function is g of x. Now let us solve this equation, that is g of x is equal to 0, to get the roots of this equation. So we have square root of x minus square root of a is equal to 0. So we have square root of x is equal to square root of a, and here the square root get cancelled, so we are left with x is equal to a, right? So x is equal to a is the only root of this equation, right? So since this equation has only one root, so the value of I is equal to 1 only, right? And let us denote this root by x1 as per this notation. So we have x1 is equal to a, right? So now the next step is to get the derivative of g of x. So g prime of x is given by d by dx of this function, that is square root of x minus square root of a. So now the derivative of square root of x is simply 1 over 2 square root of x. And here the derivative of square root of a is 0 because this is a constant. So we have 1 over 2 times square root of x, right? So now we have g prime of x is equal to 1 over 2 times square root of x. So let us calculate the absolute value of g prime of x1, right? So x1 is a because a is the only root of this equation. So we have the absolute value of g prime of a. So now we have mod of g prime of a. G prime of a can be obtained by replacing x by a. So we have 1 over 2 times square root of a. So this is simply 1 over 2 times square root of a, right? So now this side, that is the left hand side, we can write the LHS as delta of square root of x minus square root of a, which is the delta of g of x, because we have assumed that square root of x minus square root of a is g of x, right? And delta of g of x can be written with the help of this property. So we have here uh, sigma I, and we have I is equal to 1 because there is only one root. So we have the value of I from 1 to 1, right? And we can write delta of x minus xi, and here we have the mod of g prime of xi. So since the value of I is only 1, so we can simply write delta of g of x as a delta of x minus x1. And here we have mod of g prime of x1, and x1 is a. So we have delta of x minus a divided by the mod of g prime of a, right? And mod of g prime of a is given by 1 over 2 times square root of a. So we have delta of x minus a divided by 1 over 2 times square root of a, right? So now taking 2 times the square root of a to the numerator, so we have 2 times the square root of a delta of x minus a, right? So here we have got the right hand side, right? So this is how we can prove this property with the help of this important property of Dirac delta function.